So when we were putting together the conference, one of the things that was always very striking about the need for the discussion to move forward, to be very specific about the manner in which analytics and information is utilized. And so today, this panel that's upcoming is going to give you some insights into some of the activities that the panelists are engaged in regard to real practical ways in which data can be analyzed and then made available to practice. And so we're going to have, the panelist is going to be chaired by Nicole and Gardner. And Nicole is a vice president of within IBM's Global Business Service. Her bio is there available to you, and she has distinguished herself both in the public and the private sector. And in the public sector, she was with the Social Security Administration. I imagine that would be I'm going to ask you that over drinks. And now is within IBM. And I think that one of the highlights out of her bio is that she is the executive sponsor for the I'll get it right, Public Sector Women's Networking Group, which is made up of 1,700 women within the IBM group. I don't know, is that U.S., right, only? Yes, USR. And I thought that was that's a pretty exciting thing to point out. So without further ado, Nicole Gardner.
Thanks, Vernon, and thanks, everybody. It was a pretty interesting little portion that we just went through, so now we're back to sitting in our chairs. I'm just going to do a few introductions, and then we'll hear from the panel. I want to thank Vernon and Jerry and Daniel for putting together this program again. It's fascinating to see the evolution of the discussions and the beautiful charting of the conversations that we're having. I'm noticing a very distinct shift this year, which I'm sure all of you are feeling as well, which is that there seems to be a tone of energy around the possibility that some real things could be happening to break down the barriers. The one chart that had the violent things breaking down, that was pretty good. But it's coupled with a very interesting pragmatism. And I think the visualization that we just did, which makes things concrete, kind of reflects that, to say that there's a lot of conversation and philosophical concepts and ideas that we talk about when we talk about change in bureaucracy and process. But really, the outcomes change when you focus on programs and rather tactical things that you can do to get underneath what's happening and make real changes happen. And I think some of the illustrations that we had are great examples of what's possible. So this afternoon we're going to talk about some real things that are happening that are possible. And they don't require the earth to shift. What they do require is for people to change their perspectives and their points of view about how you look at data and how you can turn data into intelligence. Some of you may have seen IBM's campaign around building a smarter planet. And that's really not a brand campaign. It's an expression of a deep commitment in our DNA about what you can do with data and how you can turn that into insight and intelligence. And it's becoming a real phenomenon. So today we're going to talk about what 2 states are doing very tangibly with data to change outcomes. And hopefully those stories will inspire you about what's possible. We'll start first, and the bios are all in your book, so I won't go through those. But we've got Dr. Joe Jasinski, who's from IBM. He's a distinguished engineer, and he's our global industry executive who's responsible in our research department for healthcare and life sciences. And he's got some really interesting real-life examples to show you about what people are doing. And for those of you, we can't help it. The buzz about Watson is really fun, and it's real. What's also interesting, it's not theory, it's real, and we're going to be doing some interesting things. He'll give you a peek at what that means in healthcare, public health, and clinical. And then we're going to hear from Don Edwards, who many of you may know. He's the Assistant Agency Director for Alameda County Social Services, and we've been working with Don on how advanced analytics and real-time reporting and dashboards can have a real effect for caseworkers in determining the status of a child, along with staff members, and supporting services and programs targeted at those children who are really in need. And then we're going to hear from Bill Travis, who's working on a really exciting project in New York State around utilizing business intelligence tools around child protective intake data to predict and understand, as data is coming in, how to identify children at risk for harm from child abuse and neglect. So those are real outcomes. Those are things we're all very concerned about, and I hope you're going to be provoked to ask lots of questions around how they're actually accomplishing this, because in all these cases, the ability to share data is absolutely vital to the underlying strategy. So with all of that in the background, let me first introduce Dr. Joe Jasinski. Thanks, Joe.
It's a pleasure to be here today to address this group, and Nicole asked me to be a bit provocative, which is not something I normally have much trouble doing, so hopefully I'll provoke you by giving you some examples of things that we can do, at least in a major research laboratory today, help you to think about what you might be able to do in the future. Okay, so you're all interoperable now, right? Imagine a world you're all interoperable. You can exchange pipe cleaners of any color, shape, length, size, and so you're all going to have access to each other's pipe cleaners. That's great. What are you going to do with all those pipe cleaners? Okay, so let's talk about that a little bit. Okay. Page down, where are you? Yes, I am a distinguished engineer. I just can't run computers very well. I tried page down. Oh, that page down. Okay. Okay. So, thank you. So let's talk about analytics. Just for common purposes, let's decide on what we mean. So analytics is basically taking data, all your pipe cleaners, and interacting with those pipe cleaners with some sort of usually mathematical model to extract some information that's really valuable to you as a human being or as a business organization to get some insight. Okay, because just having data alone is necessary, but it's far from sufficient for doing anything really useful. I guess IBM has been thinking about what we call analytics and optimization for a very long time. Of course, analytics and optimization is done in mathematics. It's done in hard science and chemistry and physics, has been for years and years and years and decades. But there are much more interesting problems in the world than just chemical equations or particle physics. And so, probably our entry into this area goes back to the mid-'90s. In the mid-'90s, the IBM Research Division did one of these silly little stunts. We decided we were going to build a computer that could play chess really well. And it was going to take on the world chess champion, and because that was a grand challenge at the time. And so we built a machine called Blue Gene, or not Blue Gene, Deep Blue. I've got my blues confused there. Deep Blue. And some of you may remember this. Some of you are old enough. In 1996, he played Garry Kasparov in a game regulation match of chess, and it lost. And Gary actually came to the lab that I work at and talked for 90 minutes about what it was like to play this machine and how intense the experience was. And the conclusion was that, it would never beat him, basically. So we goaded him back in 1997, and of course, he lost. The machine won. And he did not come to the lab where I work and talk for 90 minutes about what it's like to be defeated by a machine. In fact, he actually lost his championship a little while after that. But so this is 1997. IBM almost went out of business in 1993. We got a new chairman, a guy named Lou Gerstner, a very brilliant business strategist, McKinsey consultant. You couldn't really, and Lou is really fascinating, smart, intelligent, insightful guy. But 4 years after the company almost went broke, you couldn't really go and say, Mr. Gerstner, we're very proud to tell you that we spent $100 million and we are the greatest chess-playing company in the world. Yay. That wouldn't work. So instead we said, well, what have we really done here? We've invented what we called deep computing at the time. We went and said, Mr. Gerstner, if you have a lot of data, good data, and you have really good algorithms and people to write those algorithms, and you have really fast enough computers, you can solve really complex problems. And, the business world that we operate in is full of complex problems. So they said, what can you do? Well, so over the years, we've done things like we do sales analytics. So we can analyze how our clients buy within IBM and how our sellers sell, and we can increase our own revenue by over $1 billion. We can help the Social Security Administration by analyzing unstructured data, by analyzing text for disability claims. Say that if you see certain patterns, and of course we don't reveal what those patterns are, it's highly likely that this person actually is disabled and the claim is going to be proved anyway, so you can fast track it. It doesn't need to go through the normal laborious process, and we can reduce the backlog from years to weeks. Okay? Nicole was involved in that one. She's very, very proud of it, and she should be. We can work with MTN. It's the largest wireless telephone service provider in Africa, and help them work on their customer relationship to keep them from losing customers. We can optimize electrical generation to save power companies who are trying to do on-demand power generation lots of money. And we can do something in the state of New York, which I think we'll probably discuss later. So those are some examples in the business world. When we talk about analytics, we kind of categorize it into three clumps, going from bottom to top: descriptive, predictive, and prescriptive. So descriptive, pretty much most large organizations do today. That's okay, I've got some data, I can look at the data and I can see what happened. Okay, how often it happened, if there's a problem, what led to the problem. So it's retrospective, it looks backwards, and hopefully it helps you fix things. And it's got some competitive advantage, because at least you know what's wrong. Okay, as you go up to predictive, you start to build models and you say, what would happen next? What if these trends continue? What actions could I take? Okay, and that's got a lot more competitive advantage. And then if you get really fancy, you can optimize things. You can say, not only do I understand what the problem is, and not only do I know how to fix it, but I know how to fix it in the most optimal possible way for the best outcomes. And that's what we mean by prescriptive. And then we get into optimization. How can we achieve the best outcomes? Stochastic optimization. How can we achieve the best outcomes in the face of the fact that the world is a noisy place? So, if you want to get from point A to point B in the fastest possible time, you say, well, you take the shortest route. Except if there's traffic, that might not be the right thing to do. So optimization would tell you just take the shortest street route. Stochastic optimization say, tell me what time of day it is, I'll tell you how much traffic there is, and then we'll figure out if your goal is to get there in the shortest number of miles or the shortest amount of time. And depending on what you want to do, we'll tell you how to get there. Okay? So that's just a taxonomy that we've come up with that we find pretty useful. Okay, so let me give you a couple of real-world examples. As Nicole said, my domain is healthcare, so I'm going to tend to talk about healthcare kinds of examples. Here's a project one of our laboratories in Haifa carried out with a bunch of universities in Europe mostly. It's a group called EU-Resist. They founded a group of medical research centers that wanted to work on figuring out how to better treat HIV/AIDS patients with antiretroviral therapies. And these are places like the Karolinska Institute in Sweden. And they all had data sets of the patients that they were treating. And they partnered with us and with the European Union, and we said, well, if we can get enough of these data sets together, we can build a much larger data set. So that's the interoperable part. We build a data warehouse. And because data mining and these kinds of technologies tend to work better, the bigger the amount of data you have and the more clean the data is, the more is better in this world. So they all combined their data. We built them a large data warehouse, and we worked with them to develop algorithms that would allow them to, by looking at the structured information about the patient at that point in their disease, maybe what their lab tests were, things like that, age, demographics, stuff like that, and the gene sequence of the strain of the virus they had, we could help them to optimize the best antiretroviral therapy at the first go-round. Because again, you're probably familiar enough with AIDS, it's treated with a very complex cocktail of drugs, and which cocktail of drugs administered in which way depends very much on who you are, what state of disease you're in, and what specific mutant of the viral strain you have. And so we've actually developed some algorithms that allow clinicians to, with about 70% accuracy now, up from about 60% before, figure out what's the right antiretroviral therapy for that particular patient by comparing that patient with that strain of the virus to similar patients and their outcomes. Okay, so this is all structured data. It's pretty powerful. It's now been set up as a not-for-profit organization within the European Union, and so basically anybody can go to this website and try to figure out what their patients how their patients would best benefit. Okay, but all the world's data is not structured. In fact, in healthcare, most of the interesting data is not structured. It's unstructured. It's clinical notes, it's text, it's medical literature, it's dictations, it's images. So we'd like to do analytics on that kind of data too. And so here we worked with a cardiology group, because cardiology is a domain that has lots of this unstructured stuff, And we said, what would you like to do as a cardiologist? They said, well, we'd like to know what our patient looks like at a snapshot in time. We'd like to know what our patient looks like longitudinally as their disease progresses. And most importantly, we'd like to know what our specific patient looks like compared to similar patients from this large database. Okay, because that's going to help us understand what comorbidities we might want to look for. It's going to understand if, my patient is taking drugs A and B, but most similar patients are taking drugs A, B, and C. Do I want to consider adding drug C to the regimen? So that worked out pretty well. So we analyzed things like clinical notes. We analyzed echocardiogram movies. We analyzed CAT scans. Again, extracting metadata, taking the unstructured information, structuring it so it now can be operated on mathematically, and finding similarities. And so you're not going to be able to read this, but the basic idea is that in light blue, those are the things that my patient is diagnosed with. And in dark blue are other diseases or comorbidities that similar patients to my patient are diagnosed with, but mine has not been. Maybe I should check for those. In light green are the drugs that I prescribe to my patient. In dark green are the drugs that other people have prescribed for other patients who are, again, similar to mine. I might want to check. This doesn't say you have to prescribe those drugs. It says, here's what most people are taking that are similar to your patient. Would you like to consider that? Okay. So the general idea of person similarity has become very powerful. It's very powerful, I think, in healthcare. It's probably very powerful in many areas of social services involving people who are going through various periods of their lives where if you could find patterns that were similar to other people who had successful outcomes, you might be able to steer people in a certain direction. This gets very dangerously close to what some people call profiling, which is kind of what it is. As a scientist, I can just say it's profiling. As someone in government, you may have to say a different word. It's not a bad thing. It may be illegal in some cases, and that may be a problem. Okay, but the general idea is take large amounts of data for people, cases, whatever you want to do, that have been solved, the outcome's known, and using that knowledge from data mining, extracting rules and other kinds of ideas, apply that to optimizing what you do to help the person that's standing in front of you at the moment to try to get the best outcome. It's not perfect, and that's why humans are always involved in this process, because analytics at this stage of the game is far from perfect, and it never will be perfect because we don't know all the rules. There's no algorithm. Okay. Another example, I'm very interested in how diseases spread, contagious diseases in public health. And so there are lots and lots and lots of epidemiological models in the world that describe how the flu spreads or how SARS spreads or how AIDS spreads or how lots of diseases spread in space and time. The challenge with all those models is that there's no real consensus view of what the world looks like, the underlying model of the world, how it's connected, where the people are, how they move. So a couple of years ago, we started an open source project called STEM, for short, Spatiotemporal Epidemiological Modeler, which tries to bring forward together an open source community of people who want to contribute data about what the world looks like, to build an underlying model of, in this case, the world for epidemiological purposes, and then compare actual disease models on top of that. So the picture here just illustrates if we started some nasty disease in LA on the left there where it's brightest, and allowed this to run for a couple days, the disease would start to pop up in places where you'd guess it would start to pop up, the entire DC, Boston, metropolitan area, tourist locations like Orlando, that's the thing in the middle of Florida there. So what good is that? Well, this allows you to do what-if scenarios. What if I quarantine everybody in Los Angeles? There's a fun thought, isn't it? Would it do any good? If it's not going to do any good, I'm certainly not going to go as a public official and do something that onerous if with 95% certainty it's not going to do any good. But if it is going to do some good, then I might think about doing it. What if I closed all the airports? What if So you can play what-if scenarios, and that can help you, as these models get better and better, understand what your options are. It can be used in real-time feedback as the disease progresses. If it looks like this today, and the model says it'll look like that tomorrow, what actions will you take? You take those actions, they work, they don't work, you feed it back and do over. Okay, so that's another example of advanced analytics. And the final one. Okay, so how many watched it? Don't be ashamed, you can admit it. I watched it too. I was actually on the show, very briefly. This is probably the extreme of analytics today. It's all unstructured information. It's across all domains of human knowledge. It's all in natural language. And it's entirely contextual. And it's not just natural language. It's quirky natural language that people who are clever and witty like to make up puns and things. So you're pretty familiar with game show Jeopardy, right? I'll remind you just what the basics are. You have a bunch of categories, and you have questions in those categories. You have clues in those categories, the answer to which is a question. And Alex Trebek asks you to pick a category and pick a dollar value, and you pick, and the question comes up, and he reads it. And once he's done reading it, a little light comes on over the board that you can't see on the TV screen, and that opens the buzzers, and the human contestants push their buzzer if they think they know the answer. And if they push their buzzer, buzz first, get the right to answer the question correctly, they win that amount of money. If they push their buzzer, answer the question incorrectly, they lose that amount of money, and somebody else gets to buzz and get the money. So you can't just haphazard. Being fast is important, it's necessary, but it's not sufficient. If you're not right, if you're fast but not right, you lose the game. Okay? It's also not entirely an analytics game. There's some chance to it. There are these things called daily doubles, which turn out to be very important. Daily doubles are randomly distributed, and if you get one of those, you have the right, the sole right, to answer the question, and you can wager up to all the money you've won so far and essentially double your money or lose all your money. Okay? So you have to have a strategy for that. And to get these daily doubles, since they're random and nobody can predict where they are, you have to answer a lot of questions because that ups your probability of getting a daily double. Okay, so the question comes up, what does a computer do? Well, it gets the information transmitted to it. It has to read it. It's natural language. It has to understand what that question means in a context. It has to search whatever knowledge bases, databases it has for possible answers. Then it has to develop evidence for why one of those answers may or may not be the right answer. What Watson actually does is come up with a ranked ordered list of answers and sets a threshold, and above a certain threshold it will buzz its buzzer saying, I think I have the right answer. And that threshold changes depending on whether it's winning or losing, depending on its game strategy. Okay, and the real challenge is, Watson doesn't know anything. Okay, it has no hardwired facts, and that's an architectural design point because if you hardwire facts, you make silly mistakes. So it has to do all of that in 3 seconds, roughly, because that's how fast Ken and Brad are at deciding whether they're going to answer. Ken Jennings and Brad Rudd are the two grandmasters that we played against. So that's a pretty tall order for a binary digital machine. Okay? The reason it doesn't have hardwired facts is because for a while it was having problems answering questions about months, and the guy who was the principal investigator said, this is really getting embarrassing. If the answer is a month, let's just put the 12 months of the year in there, and if the answer is a month, it'll spit out one of these things, and I will stop looking stupid. Then a question came up and said, during this month, Muslims fast all day. And it said April. And the answer is Ramadan, right? So we knew we didn't want to put hardwired facts in there, and that's why we don't want to put hardwired facts in there. Okay? So everything it does, it deduces. And it tells you how it got that answer correct or not correct. So if we go beyond the game, which again, we knew we were doing a grand challenge, it's very powerful when you want to do something really hard to empower a team with a concrete deliverable, like beat Garry Kasparov or play Jeopardy against the two best humans and hopefully win. Okay? But that's not why we do these things. Yeah, it's fun, it's great, but we are really demonstrating some pretty powerful analytics here. So what could you do in healthcare and life sciences? Well, again, this is a new paradigm for computing. The computer's not giving you an answer, because in Jeopardy you have to give an answer. That's the way the game's played. But in real life, you could give a suggestion of 4 or 5 answers, and why, how strongly you feel those answers are correct, and why you think they're correct, and interact with a human expert. Okay, so yeah, this is going back to expert systems and artificial intelligence and all that stuff that didn't work in the 50s and 60s when the words were first invented. The point is they do work now, and they work pretty powerfully. This could be a help desk assistant. It could be used in government contact centers to triage incoming requests and send them to the right place. So a lot of, I think, interesting potential applications. We're exploring a number of these. If you have ideas for where you think the most powerful applications would be, Nicole or I would be very happy to hear them. Because we do think we've really built something special here. We're working with universities. We've formed a bunch of communities around this. It's not just us. And we'd like to see if this kind of technology really can make the world a more interesting and smarter place. And I think government is a really wonderful place to think about that. So with that, I'm going to stop. Hopefully I didn't overstay my welcome.
I'm going to start with a story about a silly old farmer who lived in a valley, sunny valley, beautiful land. And one day he's sitting on his porch, and suddenly he decided, this mountain in front of me has to go. And so he's going to move this mountain. And he told his wife, and he told all of his neighbors, and they called him a silly old man. You can't move a mountain. So he got his tools, his pick, fork, his shovel, and his pail. And so he commenced out to the mountain, and he started digging and filling the pail and moving that mountain. Every day, every week, every month, for years. And they just called him a silly old man. Well, one day, the mountain gods noticed. And they were a little bit concerned. And so they went to the head mountain god and said, this farmer is trying to move our mountain. And the head mountain god goes, I'm really impressed. He's really determined. And so he instructed the other mountain gods to help that farmer move that mountain. So the very next morning, the farmer wakes up, picks up his tools, and he's on his way out, and then he noticed that mountain has been moved. Well, I'm going to tell you a real story about another silly mountain, a silly farmer, who lives in Alameda County, California, across from a better-known town called San Francisco. And we're going to talk about the social service integrated reporting system that the mountain gods liked and decided that, you know, this is something that everyone should hear about. And in fact, this is the best one in 2010. Alameda County has 1.5 million people, 9,000 employees in the county, 2,200 of them work for the Social Services Agency, normal departments, economic benefits, welfare to work, children's, adult and aging, and administration and finance, of which I'm responsible. This is our client base, 19,000 TANF employee clients, almost 61,000 Medicaid cases, 28,000 food stamps, 5,000 general assistance for people who don't qualify for anything else, and so those are county dollars. Almost 3,000 children in our care, and we help 22,000 elderly and disabled. But we had the same challenges that we've talked about here today, including, one, the 2005 Deficit Reduction Act, which required all health and human service organizations to meet this 50% participation rate, moving people from welfare to self-sufficiency. And we also had another challenge in being part of a Title IV-E waiver block that allowed us to use our funds across various programs. And we had this uneven gap between actions required and actions taken. You have multiple departments, and we have clients who cross all of those departments. Sometimes that information about that client just doesn't get to the next group. You can, telephone, email, smoke signal, none of it works sometimes. And we had this challenge of this rapidly changing environment, regulations changing almost weekly or daily. And particularly, we were data rich and information poor. Lots and lots of data. Not that the welfare system didn't have reports and data, and the child welfare system didn't have data, but because they were all disparate systems and disparate tools, they didn't communicate with one another. And so we really didn't have information about who our client really is and the services that they really deserve. And of course, the other drivers, the economic realities. And we wanted something that was not just a one-trick pony. We're building a data warehouse, a business intelligent data warehouse, using the analytics that Watson uses. But we wanted a system that was proactive, not reactive. We wanted more than just the ability to make executive reports for the executives who sit up in the ivory tower or the analysts who just love digging at data. We wanted something for everybody, including the worker. We wanted that worker to have a how am I doing button, that they can come in the morning and they can look at their 300 or 400 or 500 caseload and go, I only need to see what's important for me today. How many children were born in my caseload? How many pending Medicaid cases do I have? Who's turned 18? That's all I need to know. And so we can turn 500 cases into maybe 40 cases for them to manage on a daily basis. For the technically inclined, this is a IBM D5000 pre-configured, pre-balanced data warehouse using Identity Insight, used to be Entity Analytics. It's DB2 engine running on Cognos reporting, Linux foundations, because we didn't want people going after us, and it's web-enabled. Some basic principles: we got to have security. The system's got to be responsive to us. It's got to be multitasking, communicate, report, alert us, be proactive, monitor, always tell us what's going on, and be interoperable. We have multiple systems and multiple tools, but we want you, the system, to have to control all of that, to communicate to our interactive voice response system, for example. It's client-based. Client comes into our organization. They're enrolled in programs and activities. They are in various stages. They are associated with various providers. They have caseworkers. So that's how we were trying to build the system. Some of the internals of the system, we wanted resolved identity and the power of the social service integrated reporting system using the identity analytics that's inside it. Gives us the ability to know who's who at any given time, regardless of whether they're giving us their true Social Security number, or maybe they made an error in the Social Security number, or they changed their name. They're associated with other people, other families, other members who they're not disclosing. We wanted a longitudinal view, how people come into our system and how they leave our system. We also wanted the ability to drill down, and we wanted to be able to do this in real time, and not just, again, for the executives, but for the worker. So the worker can see not just what their case is, but who's inside that case and why things happen the way they do. Gives us the opportunity to ask every smart question every day. The system is always up. It's 24 hours a day. We don't depend on the welfare system or the child welfare system because they have maintenance to do. But because we get their downloads every day, we already have what's in their system 24 hours earlier. So we know what's going on. There are 1 billion names in this repository, representing over 200 cultures. So no matter how that name is spelled or what country that individual comes from, the system is smart enough to say that is a real person, and that is from another culture, but it's a person that has the right name in the right spelling, and so that helps us improve the way that we're looking at people. This hard-to-see graph is it's happening inside the brains of CSRS. It's identifying people based on address, but we can do a social security number, relationships, whether they're disclosed or not. I know your uncle, your brother, your cousin next door. I know you by your telephone number. So there's a multiple way of us understanding who these people are, knowing who they are, and who they are associated with. The system we're using 3 degrees of separation, but the system is capable of many, many more degrees of separation, I think up to 30. And this allows us to identify people who are also trying to hide from us as well. Just a quick example of the longitudinal view: a child comes into our system. That child grows up through our system. At one point, that child crosses over into the justice system. At some point, that child emancipates. But we want to know more about that child. They may still need food stamps at 18. They still may need welfare, Medicaid. We want to know whether they're homeless. So all of these are important things for us to know about this child, not just because they came into our foster care system, but what's going on with them as they go through our foster care system and then after they leave our foster care system. This is a 50,000-foot view of some of the data sources that are in CSRS. the Social Service Integrated Reporting System, the TANF system, CalWIN, the Child Welfare System, the probation, juvenile probation system, our in-home supportive services system, our adoption system, and our welfare to work system. And my technical team always say that if I'm going to show it at 50,000 feet, at least show the work that we do. So this is the work they do. This is a single view of our client in multiple systems. On your far left is the child welfare system. So we know the client allegations, the cases, and the placements. We know the benefits that they're receiving, the box next to it. This is TANF. So we know the benefits that we're paying. We know the programs that they're in. In in-home supportive services, we know who is being the provider and who is the recipient. In the far right, at the very top, we know whether or not you're in probation or not in probation. And all the other systems, in all the other areas where a client might have or be touching our system, we can see that in one single glance. We can see from a global view how well we're doing in welfare to work, for example. Our engagement, having people in a program and getting them through into self-sufficiency, was only 12%. Alameda, though we're probably one of the best in technology, dead last in welfare to work. But this tool is allowing us to see in detail where those areas are, and we can now target the areas that we're having difficulty with in order to improve the way that we are moving people to self-sufficiency. Currently, the systems that are in the Social Service Integrated Reporting System, TANF, Child Welfare, Probation, Employment Services, In-Home Supportive Services, Adoptions, Child Care, and our partner in healthcare, their online Medicaid department, healthcare. We have a very, very good relationship with healthcare in social services, where they are building their part of this, and they're connecting to the data warehouse, SIRS, and they're using it to determine whether or not a client is already known to the system for Medicaid application. That will cut the number of duplicates, the number of fraud, the amount of fraud, the improved service, instantly. So quite simply, the clinics or the community-based organizations log on to their OneEAP application. It automatically goes to the data warehouse, and it searches, do we know this individual? And if so, then if the information is not complete, it automatically downloads the rest of the information needed for that Medicaid application to be completed. The other systems we're adding, the child welfare structured decision making, SDM, public health death and birth records. We want to know when a child is born. That helps Medi-Cal. It helps the healthcare decide. In fact, healthcare itself needs to know what's going on, because even though the public health department is in the healthcare organization, their left hand don't necessarily know what their right hand is doing. So with this, when we know that there's a birth, we notify healthcare, and then that Medicaid application is escalated. Clients sometimes pass away, but oftentimes the benefits continue to go, and no one tells us, or we don't learn until much later. So this gives us the ability to know when a client has deceased, and we can stop those benefits immediately. We can check verification of people's income. We can look at our own employee database, and unfortunately, sometimes even internally we have a fraud. And we're adding the postal verification system, because sometimes clients move to Illinois and we're still paying benefits in California, and they just forget to tell us. Well, this gives us the opportunity to turn that off immediately. We also have our Oakland Housing Authority system inside SIRS. That actually just got moved in. Some other systems we're looking at is Medicaid, the state download, the child support database, DMV records. We're talking to the Alameda Office of Education now. One of the big challenges in the education area, particularly with our foster care kids, maybe 5% of them are very mobile. And by the time information about that child has reached the school, they've moved on to another school. Schools need to know their address, their immunization records, and we want to know about their attendance and their performance and whether or not they've been truant, because these are indicators on this child and where we might be able to get in front of problems instead of always chasing the problem. We're adding the adult probation database as well as the sheriff's incarceration records. The sheriffs are very interested in this because oftentimes when they arrest someone and bring them to the jail, they have multiple social securities, multiple IDs. Because of the identity insight technology inside SIRS, we can identify who this individual really is. We can determine that it's not the other 10 IDs, it's the one ID that they held in their back pocket. Also, clients who are incarcerated after a certain period of time aren't eligible for benefits. Again, sometimes we just don't know that, but this allows us to turn that off immediately. So our clients cross all of these boundaries, and they share, we share them in different modes. This gives us the opportunity to provide better service in healthcare and safety and education and self-sufficiency. It gives us the better idea of who our clients are, helps us improve our tracking, our client outcome, our service delivery, helps us eliminate as much fraud as possible and reduce costs as much as possible. But the other part of it is mechanizing technology and social services. Not only is SIRS doing its job, we're connecting it to our interactive voice response system, which already can communicate to our clients and to our workers and to our providers. So SIRS, as our overseer, it sees everything going on in the organization. It can instruct the interactive voice system to contact a client. We have not seen you. Our records show that you are living in Illinois, yet we're seeing benefits here in California. You need to come see us. So connecting technology to other technologies, other smart technologies, gives us the ability to take some of that day-to-day work off the worker, improve the responsiveness of our clients, and improve the opportunity for us to reduce our costs, and especially in these really difficult economic times, and improve the outcome of our clients. So that's basically it. We're always looking for new ways of improving our outcomes, reducing our actions required and actions taken gap, improving our business process. This is what SIRS gives us, and this is the opportunity that we're taking today. Thank you.
So today, we both have jobs to do. My job is to tell you what we're doing in the state of New York as it relates to predictive analytics. I think we have sort of a neat story to tell. Your job is to try to listen to this and understand it. Ask me some questions, but you got to let me know if you finish first. Okay? So that's very important. That's very important. So if you finish first, you count for the over, the under on the 18 for the ESS. So today we wanted to talk a little bit about how we are using this tool set in child welfare. Our implementation of this initiative has been very focused, and we're looking at in terms of trying to improve our child abuse and maltreatment responses. We're looking to fine-tune some of our business processes within the agency, and we're looking to determine whether or not this strategy is portable, whether or not we can take this strategy and use it in other business lines. Now, I remember when I was here, I was fortunate enough to be here 5 years ago, and there was a significant amount of conversation in this space. And then I thought it was a good idea and went back, and you get busy and you're doing a lot of things. And then we were fortunate enough to have one of the stewards come and join us before he was a steward. Jerry Pape came and spent some time in New York State helping us implement our child welfare systems. And Jerry also brought that vision with him. And a year and a half ago, we were approached by IBM with an idea. And Nicole and Ed and their team had some thoughts in the child welfare space. And so for very little money, thank you very much for helping us, for very little money, we got a head start here. It was one of those initiatives that, quite frankly, we wouldn't have undertaken on our own. You just always have so many other things to do, so many other places to put your resources. So this from our perspective, got us rolling, got us started. At the end of the day, in the child welfare world, safety is of paramount importance. And what we need to do is we need to have a better understand to allocate our resources at the front end of this process. The front end of this process is our life and death decisions are made. So we need to better understand how to make those decisions. We have a number of tool sets, and what we're trying to do now is to develop a tool set that will allow us to have better, longer-term outcomes. So how can we help initiate the plans, the case plans for families? How can we, at the front end, based upon information that we have? Like all the other states, we're in a situation where our financial resources are dwindling, our staff resources are dwindling, our ability to backfill jobs is almost non-existent. And quite frankly, the resource levels that we've seen, even in the past couple of years, we'll never recognize again. We just won't see those level of staff. So we've been asked to take a look at strategies that were effective in the business world, and that's part of the review of New York State government now, is analyze effective business practices and determine what we need to implement them within government. Specifically in my world, it's child welfare, juvenile justice, and daycare. So we had some, as I said, we had some very wise people came in and helped us. And we also had an opportunity to reach out to some of the other state agencies who had some proven success in this area. Specifically, our Department of Taxation and Finance had an increased revenue goal of $100 million that they doubled by using these types of techniques. So it was pretty successful. So toward that end, we took a look at our child welfare investigation intake process. We take 310,000 calls a year. We are a state-supervised, locally administered political construct. So we at the state take in the calls and then go through a triage process internally where we determine whether or not we want to accept the call. So 310,000 come in. We determine that 182,000 should be referred down to the Department of Social Services that would do the investigation. Of that, there's about 120,000 where the report is ultimately unfounded, subsequent to investigation, though, so subsequent to making those investments. And then we find that about 60,000 are indicated subsequent to the investigation. So you see there's like a 5-to-1 ratio here between what comes through the front end and what ultimately is indicated. So what we were thinking about was how do we better align the resources at the front end based upon 1/5 of them resulting in an indicated case in the back end. And you all know the programmatically required steps here. It's day 1 to day 60, so there's a significant investment of staff time. And you take a look at it in terms of the competition for resources. You take a look in terms of in our counties, many of them are struggling to make those mandated requirements. So what we're still determining strategically is it best to put this tool at the front end in our state central registry, or is it best to put the tool in the counties and have the county staff use this as an assessment so that they can determine where best to channel their resources? So we haven't landed on that, and if anybody has any ideas or any practical experience on that, I'd love to be able to speak to you later on about that, because we think that this best belongs at the county level, but we haven't really landed there yet. So this is the business process that drove this engagement. So will we be able to determine if a case is going to be founded or unfounded? We want to be able to prioritize those cases. As I said, there are significant backlogs. We want to make certain that we resource those cases that are going to result in improved safety outcomes. There's a number of characteristics associated with recidivism in this space, and what we're trying to do is to understand what those characteristics are, and then again make better decisions on the front end when we receive that second call or third call. Also, based upon the 60,000 cases that ultimately end up in an indicated report, there are service arrays that are associated with those cases. So the thinking is that we may be able to provide those service arrays earlier in the encounter to decrease the amount of time and influence and interaction with a child welfare system. So those are our strategies. So internally, this was, as I said, this was a new initiative for us. And internally, there were a number of our business units that we had to align. The business owner for this is our Deputy Commissioner for the Division of Child Welfare. And she was very interested in she came out of a county, so she was very interested in this tool set as a county-driven tool set. So she was an early adopter and a champion in terms of this initiative. So what we wanted to do here was to not only look at this in terms of the systems initiative, but we wanted to make this abundantly apparent to the business divisions that there was significant value for them so that we got their buy-in. So from a strategic perspective, we think that's very important to get the business partners aligned. And then also what we did was we initiated conversations with the people that were actually running that state central registry. That information is ultimately put into New York State's version of a SACWIS. So those were folks that actually used the system and input the data into it. So we felt that they were the best people to validate the outcomes based upon our modeling. So we were asked to provide a sample of about 50,000 cases, and after some testing and other sorting, about 40,000 of those cases made it into the sample. There were 3 counties for 7 years, a period of 7 years. And subsequent to creating the actual analytic queries and algorithms, there were a variety of indicators that were determined to be of value in being able to develop a model with a high degree of accuracy that could predict for us where cases would be founded and unfounded. And I'm not going to read them all, but those were the indicators or the variables that we determined that were of value. One thing that I don't think I have on here. No. One thing that we found also was that where the call originated from, so if it came from particular counties seem to be have better reporting mechanisms than others. And it's, again, it's where the call originated from. So it doesn't necessarily mean it's a child protective investigator. It just meant that there were people from those counties that were better equipped to call us. So we thought that was very interesting. Time of day, day of the week, day of the year, all were very heavily valued. So at the end of the day here, and this is after a couple of different iterations, we were able to develop a process by which 90% of the calls that we received that resulted in an unfounded case, that means a case that we didn't proceed with, could be identified at the front end. So we thought that was a pretty powerful tool, And if you are a county commissioner who is receiving calls from the state and has to prioritize those calls because you're running a backlog, you're having staffing challenges, that might be a tool that one would want to consider. So now we're going to take step 3 on this journey, and we're going to introduce some more variables. We're looking to. Sure. Yeah.
Could you tell us what accuracy means? Your definition of accuracy?
It means that based upon the outcomes of the outcomes here at the 182,000 accepted and referred, and then the report is not accepted as right there. So at those two levels. So 90% of the time or 70% of the time we could pick one or the other. Now, it's just a tool, and we're not saying at that point in time that should be obviously the only decision-making piece.
Can I ask a follow-up?
Yeah. Yep.
In what direction did you lean? False positives or false negatives? 90% accuracy doesn't tell me about specificity. So when in the 10%, the quantum of 30%, were you more likely to have a false positive or more likely to have a false negative when it was inaccurate?
I can't answer that question.
From my point of view, and I've been doing this now almost 15 years, the roadblock to getting administrators to buy in on it is the answer to that question. They don't buy in on such an instrument unless you can tell them whether they're going to miss cases that will later come back to them with injuries, or you're going to over-label people substantiated who in fact don't merit services. Without the answer to that question, this really isn't going to.
I'm going to ask one of our analysts to help us with that question. Ed?
Excellent question. So the first thing I want to point out is this project is still in process, so we're still fine-tuning and developing the models. In terms of the 90% accuracy, what we're doing here is taking the intake data only, the stuff that comes into the SCR, which is not much more than some family demographics whether or not the person making the report is a mandated reporter or not, and the allegation. That's the data we're working with. We're comparing our assessment of that data to what the investigators find when they actually go out, do the investigation, and make a determination. So that's what we're trying to predict. So for those unfounded cases, we're 90% accurate at predicting which of those cases at intake are going to wind up unfounded. We're erring on the side of, in the case of the unfoundeds, the error we've tuned the models to is to err on the side of saying it's indicated. Okay? So our errors are false negatives, the negative being it's not unfounded. The other error we've chosen to make is for the system to come back and say, you haven't given me enough data, so it's indeterminate. So those are the two types of errors we're trying to make with this model. Either we don't know, or we're going to err on the side of saying it's indicated when it's not.
It's a false positive.
It's false negative.
But you're erring on
The negative is unfounded.
The negative is unfounded.
We're erring on overprotecting the child.
It's a false positive.
So you're not.
We're predicting unfounded. So it's a false negative. It's a double negative.
And some of those were found.
Unfortunately. Okay? It's a double negative. Okay?
So our next step is we are going to begin to use our data in our child welfare system in a real-time fashion to set up a shadow system so that we can begin to better validate some of the percentages that we're talking about right now. But we're very optimistic that this tool set could have value in the field. And again, it would be another tool, another assessment technique, not the tool set, but another tool where we might be able to help people make decisions. We're continuing to meet with our internal stakeholders, and they're starting to ask many questions also about what type of information we could provide them, and they have some ideas for reports that I think will be progressing soon. But I think that this initiative now is beginning to move from a strategic initiative as we begin to fine-tune this information, and we expect to bring it to our New York State Public Welfare Association commissioners at the April meeting to talk in detail with them about this and get their feedback and determine how they may want to take this also. But we think that this toe dip was one that was well worth taking, and we found that the results to be encouraging. And quite frankly, I think that this is an initiative that, given all the financial concerns and the staffing concerns I talked about, I think this is an initiative that is sustainable because the lift at the end of the day after we finish developing these models is not that great. So I think with that, I'm going to tell you, the over-under was 4. You did a great job. No one seemed to finish first. And I want to thank you very much.
So do we have questions? More questions? Marty? Rockstar.
When it would pick a new question, when it would pick a new question, did it assess all of the categories and figure out which category it knew the most about, or was it entirely random?
So no, I didn't talk about, and I'm not an expert in this, we had an entire team that was in charge of the game strategy, because in addition to doing all the natural language processing and figuring out if you have an answer, there's a whole strategy around playing the game. If you watched it, you can pretty much guess that the lowest level strategy is pick categories that are harder for humans. So if you got a choice between sports and romance literature, we're going to romance literature, right? Because most humans aren't too good at that, and Watson is equally good at sports and romance literature on average. So that was the basic strategy. There's much more twists and turns in there. The other strategies: how do you bet on the daily doubles? How do you decide what to bet? Because if you did watch the game, the second game, the reason it ultimately pulled it out against Ken Jennings was because it got a daily double and it bet very aggressively.
Thank you.
So how about back to human services?
I think there's a comparison to be made between Watson and the welfare system. Because the question isn't whether you can improve on 90%. The question is whether the 10% that are misclassified, is the algorithm or is the computer model going to do better than a human? So what are your data? I mean, when a case goes through the system, what percentage of the time do they miss?
So let me just comment
Good
on that.
observation.
Yeah, can I just comment on that? Oh, well, he wants to comment.
Starting with Peter Rossi in 1994 until the present, the humans do no better than chance.
Yeah, so again, the
It's
comment,
as if the two contestants against Watson were simply guessing A, B, C, and D without content.
So the other thing to think about, and this is hard because it's a social norm that we have, people are allowed to make mistakes because they're human. Computers are not allowed to make mistakes. So it's been shown in a number of studies, a number of disciplines, in radiology, for example, that machines today can actually read mammograms more accurately than doctors, but not perfectly. Okay, so maybe the best radiologists do about 95%. Machines, I'm making the numbers up, maybe machines do 97%. We're fine with the doctors doing 95. We're not fine with the machine doing 97, even though 2 more people out of 100 would be diagnosed properly. And how do we deal with that as a human society?
On the last question, and then I've got a follow-up. There is some pretty solid national data that frontline workers, when the issue is substance abuse, and when that can be verified by diagnosis after the fact, frontline child welfare workers miss that 61% of the time. So starting from that baseline on that particular leverage issue, you got a lot of room for improvement. My question to Don, I think, is related, and you mentioned reduction of costs in passing. Tell us a little bit more about that, and tell us whether in that cost reduction, it's possible in the fiscal climate that California is in now, to have taken smarter cuts as a result of the data system you've got than the across-the-board or other kind of cuts that you would have had to take without it.
A real good example of where we can improve process and save costs is in looking at that gap between the actions required and actions taken. And we did an analysis that identified several thousand clients who were receiving benefits yet not participating in welfare to work programs as required. And many of them are avoiding the system. Some of them are probably, maybe have really good reasons. But in that gap, there's millions of dollars that are being given to clients who are not participating in welfare to work programs that if we were better at business process, could reduce that number. And those are taxpayer dollars that could go to people who actually deserve the money.
But wouldn't you want to know whether those were moms who had to go back to work with California's extraordinary 3-month requirement? Wouldn't you want to know that instead of just saying that's all money saved? And does it tell you that?
Yeah, it does tell you that, and you're right. There are moms in that group, and we're not saying we're going to cut benefits off of moms. We're saying that every person who is eligible, who is employable, and are not participating in programs ought to be participating in programs. And there are a lot of exceptions. So even if you cut the number in half, if you exclude the moms, you have the others, the single individuals who are not participating, and those are also people that you would want to look at.
So question for Don and Bill. It's the obvious question for this group, which is how generalizable are these analytics that you've developed to other states? And given that you guys have gone through all the trouble of developing them with, public money, are these algorithms that can be made available to for the common good?
Well, we brought the system on for benevolent purposes to help us improve our services across the board. But the DNA of this identity insight technology lends itself to also looking at the other opportunities, particularly now with our budgets being cut, that we should look closer at internal and external fraud or waste that our systems have.
I think to the degree that the data and the algorithms reside outside of the proprietary software that IBM owns, I think that we can make them available. There are we have some of the queries are in SPSS, so I think those could be available. I think that to the degree, however, that you have different data stores than we have, I think that there could be some data reconciliation required too.
Yeah, this is for both Don and Bill. When you get this data and you have this analysis, do you use the data and the analysis to make a decision to take action on a case, or do you use that information as a red flag to let you look further into the case? So, for example, an action that you might take in a sanction or something, would that be based on the data only and the analysis only, or would you use the data and analysis to make you then contact that client and delve further into what looks like a red flag to you?
Our approach is to only automate the business process. So if it requires a human intervention, because we don't know, I mean, the system is telling us here is a potential, but it still requires a human to do further investigation. Now, in the case of a client who is living in Illinois and receiving benefits in Oakland, that's an automatic. You can turn that off. And what we find, because we do this manually too, what you find is if you make a mistake, that client calls you right away. So it's whether it's automated or manual, it's the same process.
I think in the child welfare world, it is another tool in a safety assessment. So we would not take any action on the case based upon the results that we determine from our tool set on the analytics side.
My question is about the predictive, when you talk about 70%, 90% accuracy according to who? It strikes me that the only thing you can be comparing to is an actual social worker's decision who people have gone out of their way to tell us is not necessarily accurate in the first place.
Well, all I can tell you is that based upon the number of cases that are ultimately founded versus the cases that are unfounded. Those are our two data points. In terms of whether they made the right decision, I don't know.
Okay, that was my question.
I've got a question for the whole panel. There's a lot of energy going in right now to something like a master client index or a shared persistent person identifier, or however you want to say that. Do you predict that that effort will be pointless because of some of these new identity matching techniques that you're applying?
I'd be happy to go first if you. We found that in our state, most programs have their own unique individual identifier. So as a result of that, there really is no unique identifier. So toward that end, I do believe that from a master data management perspective, there will be a number of algorithms and strategies defined to manage identity. Whether it comes back to like the master unique identifier that you're given at birth or when you enter school or something like that, I'm not going to speculate on that. I think that right now the way the industry is going is more of an analysis of a set of data rather than a singular identifier. You guys can say whatever.
I don't really see a conflict because what we're looking at is the resolution of the individual to determine who this person is across all the systems. And the NIE, for example, has its own capability of identifying who the individual is. What we do is say that Jane Doe and Jane R. Doe and D. Doe are the same individual based on the information that we have. And then the information that comes across to us, for example, from healthcare, can ask for information for Jane Doe or Jane R. Doe or D. Doe, and we will know who that is. So it's a complementary process.
Yeah, I think that's an important aspect because even suppose there's nothing perverse intended in the system, no one's trying to hide from you. My last name has, I think, 8 letters in it, and it's Polish, and so there are a lot of potential ways it could be spelled, not by me necessarily, but by people who are trying to help me. And so what these tools do actually, even they can identify me even if my name is misspelled based on other characteristics, so they are complementary. It's not that I was trying to hide from the system. It's not that I was trying to do anything wrong. Somebody put SKI and SKY.
So I guess it's for Donnie and thank you. For Donnie and Bill, can you talk a little bit about who's using your systems today, how far down in the organization to the caseworker level, and what went into those decisions, particularly around not necessarily even just what information they're allowed to know, but what should they know? Is it, for instance, for a child protective service caseworker, should they know that there's unlikelihood this will be found a founded case statistically? That seems, I think a lot of us may be uncomfortable with that because then they're not looking at the whole facts of the case necessarily in a individual basis. And then for Alameda County, are they, if I'm a similar circumstance, is it important to me as a CPS worker to know, or should I know, that maybe the mother was formerly in juvenile justice before in making my investigation? Is that appropriate?
I think everything is based on need to know, and we build our systems based on need to know. So, for example, a child welfare worker would want to know about probation and about child welfare, including eligibility information. However, an eligibility worker has no right to know about that child or about probation. So in the way we've built the system, even though you saw the full view of the client in my presentation, the eligibility worker can only see eligibility information, perhaps in-home support services, provider, and recipient information, but not information regarding that child. As far as who gets to see the information top to bottom, every worker, every supervisor, every manager has a level. A case worker needs to see everything in their case, and so we give them complete drill down to all of the services, all of the benefits, all of the activity for that case.
I'll just talk about New York.
Oh, sorry.
Bill's going to answer.
I was just going to say, in New York, sorry, we're still at the executive level. We have not provided this information beyond the commissioner level. It's part of the conversation we're continuing to have. So I really can't speculate at this point in time, but I don't see this becoming part of the information that we would give probably much lower than like a director of services with our business construct.
Hi. I was just wondering about the, I think right now we have descriptive information and we're moving to prescriptive. And then if you were going to go to the next one, I mean predictive, I'm sorry. And I was, because I've been really fascinated by Watson and what could it mean for social services where there's a lot of behavior as opposed, I guess there is in medical too. But at any rate, if it's based on data from the past, whether it's predictive or prescriptive, and we know that there's things like racial bias, ethnic bias, all those kind of biases, gender bias built into the past, then how do we, is there a way like to control for those so that we wouldn't build those into the future? Because we know that there's an overrepresentation, for example, in care, juvenile justice, lots of things have children of color. I'm just trying to figure out, like, how do you've got to base it on the past, right? And that it's already built in, so how do you counter that? Or is there a way to counter it?
We certainly recognize that there's disproportionate minority representation in the population. So you have the ability to provide different weights for different factors. And I'm not saying that this is the way that we do this, because we have not gotten to that level yet. But when I talked about fine tuning and getting the second phase here, where we were able to increase the outcome percentages, it was a function of fine tuning some of the factors. So that could be a strategy, but we have not done that.
When I leave here on Thursday, I'm meeting with with city officials and the police chief and some board members, and their question was, how can CSRS help predict crime? And I don't think anyone can predict anything unless you're using one of those 8 balls. But what you can do is assess probability. And there are 2 kinds of processes. One is static, and the other is acute. And when you're looking at static data, you fall into the trap of disproportionality. Black man, he's 20 years old, he's been in jail before. This guy, throw him in jail. Or Caucasian boy, he's using powder cocaine. He is also using meth. He's had some psychological problems. He just got out of jail. Here's somebody that you might want to take a look at. He's doing something now. So the difference is, how do you use analytics in a real way? You have to use acute data. What's going on now versus who this person is. And the way I am going to explain it to the people that I'm going to talk to is, in using SIRS, what we really want is the community. We want the sheriff's information. We want health care, behavioral health care. We want the schools. We want all of those items, those areas where we're touching those individuals. We want the La Clinica CBOs, community-based organizations. We want all of the groups, this village, who have a stake in our community to participate. And it has to be active. It has to be what's going on now. So, in predictive analytics, from my perspective, we need to predict the probability of someone who is currently doing something right now. This guy with this GPS who is now at a school. Well, this guy is grooming. We know that this past sex offender is going to do something again. But the way technology is, even though the GPS is working and the police may get a record that this person has gone there, they are not necessarily monitoring this on a day-to-day basis. However, if we stick it in a system like SIRS, where it's proactive and we can use the IVR technology to call the police or call that person's probation officer and say, your client is grooming again. And so that way we can get in front of these items. That's how I think is the way that you really want to prevent crime, get in front of it. And if you can save one person, just think of the cost of imprisoning someone. $400,000 to put someone in for 5 years versus $15,000 to do prescriptive support for that person. So that's our approach.
And the only other thing I'd like to say is, in designing these systems, you have choices about how to test them, right? The data is the data. If there are biases in the data set you use, you should find those biases. That's a good thing or a bad thing. It's a bad thing if you don't realize there's biases, but it can be a good thing because it can actually help you identify what variables not to use, like race.
It seems to me also, though, with this kind of analysis, that you would want it to be dynamic, you would want to constantly have feedback loops, because trends change also, and one way is if you're aware of the fact there are biases, then you can start to filter them out as you start being able to identify the kinds of things that indicate bias that may be in the past data. But it seems to me in all these things you need a dynamic way of approaching things. It's not, you can't just calibrate it once and then use it, which is what a lot of people think it is.
I had two points I wanted to make. One, Don, I was curious, you had education up there. How are you working through FERPA and HIPAA when you are sharing data across systems? Because you said it's coming, so I'm assuming that you've done some thinking on it.
Yeah, we're talking, and we're talking about, well, what is it we can share? And our perspective of HIPAA and FERPA those are guidelines for us to work with. So they're telling us how we can share, not that we can't share. And so there's certain information that I do want. I want to know about that person's truancy. I want to know how well they're doing in school. That's information that they can share with me. They want to know whether or not this child, they want to know their address. They want to know whether they're coming to the school and their immunization papers are all in place. That's information that we can share. So with our MOU, as we build this, we don't try to tear down walls. We're trying to work with the rules that have been given to us.
So and your attorneys are comfortable with that position, that it's just a guidance?
Well, we write MOUs. We also have bench orders from judges.
So you don't actually get a parental consent on the books to share information about the child across systems right now?
Only what we're talking about the kids that are the ward of the courts.
Oh, okay. Okay, got it. The other question I had, and this might be for the room as a whole, we've been using we've all talked about structured decision-making as a predictive tool in child abuse and neglect. Now, New York has built another tool that potentially is predicting potential for child abuse, or indicated findings or unfounded. And maybe Dr. Gellis has more wisdom on this. How do we make sort of choices? Let's say, Bill, your product is very portable and it's available, and it's 2 years down the road, and you really do have something that offers portability across states. Part of the question of sort of what's a false positive, what's a false negative, how do you make these decisions? Are there specific opportunities we should be looking for, criteria that should drive decision making, even for policymakers?
There's a question for Richard over there. Say that again. Do I have my full arms around this?
Well, my question was, as we've been talking about structured decision making for a long time. Lots of states have looked at that as a possible predictive tool.
Yeah.
New York now has another one that's showing promise. As we're thinking about across the country about different decisions, what kind of criteria should be applied for this?
New York's is better. We analyzed this at Penn 2 years ago. We started out with clinical decision-making, consensus risk assessment, structured decision-making, and what I think New York is using, which is a version of neural nets. And the bottom line is, and I guess I should reinforce this, no matter how much experience the social worker has, or caseworker has, no matter how much information the caseworker has, the caseworker on his or her own never does better than flipping a coin. They might as well walk into the house and flip a quarter. That's as accurate as they're ever going to be using clinical judgment. Consensus risk assessment is no better than chance either. Structured decision-making is a static decision-making tool that's validated for the community, but it doesn't allow you to input data in real time and readjust as the community changes. So it may be accurate the year you buy it, 2008. It may be normed against your community in 2008, and then at the end of 2008, the economy goes down the drain. There's been an immigration inflow or an emigration outflow, but what you bought was accurate for 2008. What you've got in the New York system with IBM is a system that is going to be as good as the data you put into it. So they have the ability to improve it, but it's an always dynamic model. So that as the economy changes and the population changes in New York, they are going to move from 90, probably the threshold in this is probably 95%. You probably won't ever get higher than the 95% specificity. But if you're going to go to Best Buy and you're going to choose from these 4 items that are on the rack, the best research that is available says New York's doing it the right way. The only question my only reservation about New York is keeping it in the administrator's hands is sort of like having risk assessment for coronary artery disease and only letting the hospital administrators have it, and the poor docs are using clinical judgment out on the ward. Someday, maybe in a year, 2 years, 3 years, people will have the confidence to give these instruments to social workers and caseworkers because they have to make the decision in real time, and they will make vastly, according to the research that's available right now, they will make vastly better decisions. The colossal amount of money that every state wastes, the elephant in the room here is that 80% of the families that are investigated for child abuse and neglect get nothing other than an investigation. They get no services. They get no voluntary services. Every cent of that money is on the shoulders of the state and the locality. There's almost no federal money. There's a little tiny bit of captive money that flows into it. if you were going to look for a place to be more efficient and more cost effective and make better decisions, you could do no better than what New York is doing, except you would let the caseworkers have the data.
I just want to add, this is exactly what the Social Security Administration's learned over the last 6 years, and they are now aggressively pushing it down and spreading it out. But it's taken a few years to get there.